another. Here is an array of magnets, and inside a coil of wire. And here is a lamp connected to that coil. I'm going to do mechanical work on the coil. It requires a force to turn the crank, to turn the coil, and watch the lamp. Obviously, I have converted mechanical work to electrical energy, and the electrical energy has been converted to thermal energy because the filament in the lamp got hot enough for us to see. It emitted light. Or another wonderful one. Here is a slab of lucite, plastic. And here is a cat's fur. And I am going to do some mechanical work. Here is a metal plate with a handle. I'm going to put the metal plate down on top. I am not discussing the electrostatic changes that are taking place. I'm going to ground the upper surface of the plate. Oh, I felt something. And now, listen, listen, listen. Oh, there was a spark. I'm going to do it again. There's a spark. Indeed, here is a fluorescent lamp, and I think that if we quieted the lights in the studio, you will see that I have produced enough electrical energy. We need all the lights, I think, in the studio to see the lamp. Yes, I saw the lamp flash, but of course the lamp is too much lighted by the lights in the studio. Let me take another lamp. Here is a tube that is filled with neon gas, and I want you to see the flash of that tube. Watch it. Yes, I saw it. There it is. There it is. I'm going to do it again. And what have I suggested by this adventure? I have suggested that we can do some mechanical work on that dielectric, which is the slab of lucite, give rise to a separation of the charges, and then draw electrical energy from this system. And here is a comment about which I shall speak more adequately when I do a program on electrostatics. I can continue to draw this energy from this system forever without any diminution in its availability. That's a fantastic thing. Now somebody says, did you say, Professor, that you can continue to draw energy from this system forever without any diminution, any lessening in the amount of it? And my answer is yes. And forever is a very long time. Consider now another little classic, quite enchanting. There arises often this little problem. Here is a perfume bottle, and the glass stopper is lodged in it so firmly that it cannot be removed. Now, what do I propose to do? I propose to get out the stopper. There are all kinds of methods for doing this. Heating it in hot water, heating it with a flame, pouring some solvent down through where it fits. But here is a wonderful way to do it. A piece of string wrapped around the neck, and such action. Now, what am I emphasizing in all of this? I am emphasizing a very important subject, which is a terror for the human race. Friction. Friction. And what must we say about friction? We must say this. We spend untold measures of money and effort to minimize friction, reduce it, get rid of it. But is not this something to think about? If we were successful in eliminating friction, there could be no motion of any sort. Meaning that if friction were at this instant annihilated, undone, disposed of, I could not move from this place, except perhaps upward. Oh yeah, I could do that. But I couldn't go forward. Supposing I did go forward, I could never stop. So if now, at the switch of my fingers, friction were eliminated from the earth, all motion would be quieted. Every automobile would be brought to rest. All the ships on the sea would stop moving. Maybe the astronauts would keep going because they are in empty space, and having once acquired the motion, they go without effort endlessly. Now, where are we? Oh, more on the matter. Production of heat. Bicycle pump. You know you connect it to your bicycle tire or your automobile tire, and you pump, and what happens? The piston gets hot. Heat energy converted from mechanical. Or consider a simple one that is most dramatic. Here is a paperclip. What shall we do? It is now at room temperature. I bend it. I bend it. I bend it. Uh-oh. I cannot hold it anymore. It is too hot. And what I would ask you to think about is the astonishing behavior internally of those little molecules and atoms of stuff which are put into fantastic agitation. And this is a mode of motion which describes this thing called heat. And I thank you for listening.